China has achieved a significant breakthrough in drone warfare technology, successfully testing drones that can be fired from 155mm artillery shells. After more than a decade of technical challenges and expert skepticism, Chinese military scientists have confirmed that their artillery-launched drones can survive the extreme forces of shell launch and function as intended. According to a recent South China Morning Post report, the tests were conducted at a military base in western China. Chinese drones survived launch forces 3,000 times their own weight and traveled more than 10 kilometers in seconds, tests show. 5 live fire trials at a western test base confirmed the drones endured launch forces exceeding 3,000 times their own weight, comparable to 35 adult African elephants on a person. The advance centers on a pyrotechnic ejection mechanism co-developed by the Shaanxi Applied Physics and Chemistry Research Institute, the Chinese Air Force, and defense contractor Norinco. This highly reliable but low-cost system orchestrates a sequence of precisely timed detonations to separate the drone from its artillery shell mid-flight while shielding it from aerodynamic damage, all without electronic controls. These drones can reach distances exceeding 10 kilometers, 6.2 miles, in seconds, multiply flight range, significantly save power consumption and extend loiter time, the team, led by senior engineer Huang Yunluan, wrote. First proposed by Chinese military scientists in 2013, a cannon launching design named Tianyuan Sky Eye gained attention in a new concept aircraft competition, according to state-run China News Service. Recently as last year, Chinese military experts speaking to state broadcaster CCTV said such systems were impractical, citing the destruction of sensitive electronics under high G-forces. Instead of relying on fragile electronics, the senior engineer Huang Yunluan led the team to a robust mechanical system. Their solution, an 8-stage chain reaction using explosives, flame channels, and pressure chambers to eject the drone from the shell mid-flight, remove protective panels, and ready the system for flight, all without any electronic controls. The device is built around a hardened stainless steel structure capable of withstanding 1,100 megapascals (MPa) of pressure. According to internal impact tests, explosives such as lead azide and boron-based compounds survived internal pressures up to 36,000 times the force of gravity. Once launched, the drones can travel over 10 kilometers, 6 miles, in seconds, saving energy, increasing flight range, and extending loitering time for reconnaissance or targeting missions. The system also uses a maze channel design. This allows controlled flame propagation through 4 small 1mm holes to ignite each sequence phase while preventing destructive pressure spikes or debris blockage. However, with continued support from China's central government and military funding, researchers have demonstrated that it can be done.